Hello there, 6th and 7th hour pre-algebra classes. Sorry I haven't been able to be with you the last couple of days. Kind of threw our schedule off a little bit, which I'm sure you're terribly sad about. Hopefully, I will be able to be back on Thursday. And if I'm back on Thursday, we will start the test on Thursday. And I suspect I will end up giving 2 days to take the test so you don't have to feel rushed. But you remember you can use the study guide on the test. In fact, the study guide will be the primary way that I will even address or answer questions that you have about the test. If you ask me a question on the test and you do not have a completed or filled out study guide, then I probably will not give you much help on the test. But if you have your study guide filled out and have it with you, then I will talk you through the one on the study guide and maybe even help you see how it relates to the one that's on the test. So this is your lifeline, guys, for the test. So make sure that you have it done and don't lose it. Okay, here we go. We're just going to work through all these. I'm going to do every problem on the study guide, and I'm going to try to go kind of quick, actually, through these because there is a video. You can pause it. You can stop it if you need to catch up with the notes or whatever. That's fine. But I want to make sure I get it all in one class period. So I'm going to kind of go through these examples pretty quick. Select all the equations on which the point 2,1 lies. So with every ordered pair, we always have an x and a y value. And in every one of these equations here, there is an x and a y value. So all I have to do is substitute the 2 and the 1 in for the x and the y and see if it's true. If it's true, then I circle it. If it's not true, I'll cross it out. So that would be 1 for my y value, right? 1 equals 1/2. That's this 1/2 right here. And then my x value is 2. So that's y equals 1/2 x, just like we have in this equation. Y equals 1/2 x. Now I just have to multiply this. What is 1/2 of 2? Well, half of 2 is 1. So 1 equals 1 is a true statement. So that one gets circled. We'll just do the same thing all the way down. We'll put the 2 in for x and the 1 in for y. So I'm going to do 2 times 2 plus 7 times 1 equals 11. 2 times 2 is 4, plus 7 times 1 is 7, equals 11. And guess what? 4 plus 7 equals 11. That's true. So we'll circle this one. 5x minus 3y equals 4. So we'll put the 2 in for x. 5 times 2, and then minus 3 times 1 equals 4. Well, that would be 10 minus 3 equals 4. Well, 10 minus 3 is 7, and 7 does not equal 4. So this one's false. That means this line, this is a linear equation. We could graph this and it would make a line on a graph. It's just that the line would not go through point 2,1. It would go through other points. Okay. X is 2 minus 2 times 1 equals 0. Well, that comes out to be 2 minus 2 equals 0. That obviously is true. 2 minus 2 is 0, so that one gets circled. And then my last one here, y is 1. Be careful not to do this one backwards. So 1 equals negative 2 times 2, plus 4. So that would be 1 equals negative 4 plus 4. And that comes out to be 0 equal, or whoops, I wrote it backwards. 1 equals 0. And that's not true. 1 does not equal 0, as you well know. Whoops. So instead of circling it, I'll cross that one out. So your first question on the test is very similar to this one. It's got the same words. I think different ordered pair, different equations. So that's how you do question 1 on the test. All right. Scroll down. Number 2, the owner of a donut shop Made a graph to chart the sales of 3 new donut flavors over the course of a month. Explain the meaning of the slope of each line for the donut it represents. And I'm going to cheat a little bit on this one. I'm going to, instead of handwriting these, type them because you guys have seen my handwriting and it's not pretty. So let's see how that looks. That's a little big. There we go. So for line A, that's this red line here. I can even type it in red. That'll be cool. There we go. For line A, this line starts out kind of low, but then it goes up all month long. So we look at this. This is the days of your month, and these are how many donuts were sold. So for line A, started low, but then they sold more donuts every day. Something like that. It doesn't have to be that exact sentence. It just has to get that idea across. You could say, there's just a dozen ways at least to say this. So don't get hung up on the exact words that I use. Just understand the concept that this line is going up. That means it starts with a low number of donuts, ends with a high number of donuts. You could even say that. Something along those lines. Now line B. So line B, line B, they sold the same number of donuts every day. Okay, so line B, every day, this number of donuts doesn't change. So just something that gets that point across. They sold the same number every day. The number never changed. However you want to say it is fine, but just get that point across. All right, the last one is this purple one, line C. Oops, I thought I switched that. Line C. Started at a high number and ended at a low number. Something like that. Again, just something that gets that point across. On the first day, they sold a lot of donuts of that flavor. By the end of the month, they weren't selling very many of that flavor, or it got less popular during the month, or whatever. So I'm not looking for exact words on those. I'm just looking for the idea that you understand what the line on the graph represents. This is a different scenario than the graph on your test, but you'll have a very similar graph and very similar question about explaining the slopes of the lines. Okay, so that's the kind of thing I mean when I want you to have the study guide filled out. If somebody calls me over on question 2 and says, I don't understand this question, I'm going to say, well, show me your study guide. And if you have these written out, I'll talk you through these on the study guide. See how line A starts low but goes up, and we'll talk about it. And then same with line C and line B. We'll talk about what they mean, and then I'll point to the graph and I'll say, now what does this line mean? And I'll try to help you see how they relate to one another. But if you don't have your study guide, there's not going to be any way I can help you. Okay, I think I've got my point across on that. I want you to have your study guides filled out and with you. Number 3, a warehouse has 2 freight elevators, one large, the other small. The large elevator can move 4 pallets between floors every minute. The small elevator can move 2 pallets between floors every minute. Which of the graphs below best represents the number of pallets moved by the elevators? So let's get where we can see all 4 of these graphs at the same time, because there's 2 of them we can eliminate right away that are not set up the way we'd like graphs to be set up. And we've talked about this a little bit. I've tried to emphasize it a few times through the chapter, I think. But we need to always, almost universally, it's going to be true that there's a specific place we want to see time on a graph. Do we want to see it on the y-axis, or do we want to see it on the x-axis? And I can't hear if you're giving me a response or not, so we'll just jump to the answer. We want to see time on the x-axis. If this is x and this is y, on all of our graphs, of course, but we always want to see time on the x-axis. So for these two, we're going to cross these out without even really looking at it, because once we see that time is on the y-axis and the pallets moved is on the x, that just is not going to graph correctly. It's not going to graph the way we want to see it. So time needs to be on the x-axis. So now I've already eliminated two possibilities, right? And you know what? For a study guide, it'd be awesome if you just made a note. Time, goes on x-axis. And if you have that written down, that will help you, I promise. Okay, time goes on x-axis. So now, does it make sense if this is number of pallets moved? Does it make sense for the large elevator to be climbing at a slower rate than the small elevator, or does it make more sense for the large elevator to climb at a faster rate? Well, the large elevator moves more pallets per minute, and so you would expect that number of pallets to be going up faster. So it is B, the one that we're looking for. And there's really not a whole lot of work that you can show on this one, or not much that I want to see. As long as you kind of are able to eliminate the ones that need eliminated and everything, you'll be fine on this one. Just choose the right one. Okay, I know your your copies of the study guide are not in color. The day I tried to print them for you, the color copier was out of toner. So your test, when I get it done, or when I get it printed, I should be able to print it with a color copier, and it will be easier to see the lines on the graph than on your study guide. So I apologize for that. But hopefully you can kind of pick them out on my screen and see where they need to be. So let's start out with line A. We're going to write equations for each of these lines, line A, and there's two things that we need to write slope-intercept equations. And slope-intercept equations, of course, look like y equals mx plus b. And the two things I need to know are the y-intercept and the slope. If I know those two numbers, then I can substitute them into the slope-intercept equation and have the equation of the line. So for this letter A, this red line, there's the y-intercept. So I just start at the origin, count 1, 2, 3, 4. So it is a positive 4 y-intercept. And then first thing I notice about the slope is it's going down from left to right. So that means it's a negative slope. So I'm going to put a negative symbol there before I even count so I don't forget about it. So now, excuse me, from here I can go down 1, right 2, down 1, right 2. That's my rise over run. Down 1, right 2. So it's a negative 1 over 2. Now just take these two numbers, put them into the equation. Y equals negative 1/2 x plus 4. And that's the equation for this line. Okay, let's do line B. So line B is different. We can't quite follow this pattern because it's a vertical line and our slope is undefined on a vertical line. So for a vertical line, it's just going to be x equals, and then count from the origin until you get to that line. So from the origin is left 1, 2, 3, which means x equals negative 3. And I would put something in my notes about this. I would put vertical line is, and then put like x equals a number, right? Okay. Whoops. Wow, that got out of hand really quick. That escalated quickly. Okay. So x equals a number is what I want to see anytime you have a vertical line. And so, man, circle that. Put a star next to it in your notes so that you'll remember this. These should be the easiest ones. That B and D should be the two easiest equations to write if you remember the rules. And if you don't remember the rules, why don't you have them written down? Write the rules down and make those two that you are sure to get correct on the test. Okay, C is going to be more like A here, where we have to find the slope and the y-intercept. So slope, or y-intercept rather than slope. B is 1, 2, 3. So B is down 3, which is negative 3. And then I notice it's a positive slope. So I need to count up 1, 2, right 1, 1, 2, 1. So the slope is 2. So just take those two numbers, plug it into the slope-intercept equation. Y equals 2x minus 3. Alrighty, and then finally, line D. D is a horizontal line, and if a vertical line is x equals a number, then a horizontal line is y equals a number. Oops, I should put D equals. I guess I don't have to cross that out. D would be y equals 3. No, whoops, I didn't know how to count. 1, 2, 3, 4. Sorry about that. Y equals 4. Whoops. See how easy that is? And I would do the same thing on this one. This is a horizontal line. And that is y equals a number. All right. That goes on your study guide. And when you see this one on the test, you should be able to get those horizontal and vertical lines very easily, I would think. Okay, moving right along. Here we go. All right, more into some of the word problem stuff. This first one's not too bad. A flour mill has 3 production lines. Line A produces flour at a rate that is demonstrated by the equation F equals 5H, where F is the total tons of flour produced, so that's total tons of flour produced, and H is the hours of production. So flour equals 5 times the number of hours. Okay? Is the way that equation kind of represents itself. This is a proportional relationship, right? A proportional equation. We should recognize that equation form. And so the K value on this first equation, K value, you should recognize that as 5. That's the constant of proportionality. And that K value of 5 for this one means 5 tons of flour. 5 tons of flour every hour. So 5 tons per hour. So if they run the line for 10 hours, they get 50 tons of flour. If they run the line for 2 hours, they get 10 tons of flour, right? So that's the way that works. All right, let's look at this next one. Line B, so the second production line is represented by the table. Here's the table. So hours and tons of flour represent the same thing from the letters in the equation above. So for this one, we need to figure out what its rate of production is, what its constant of variation or constant proportionality is. And so we would just take any of the y values and put it over the x. Remember, our typical equation would be y equals kx. And so h is where the x goes and f is where the y goes. So we would do 8 over 2, that's y over x, and that equals 4. So this one would have a k value of k equals 4, and that's 4 tons every hour. And then we look at the graph. In the graph, we notice, first of all, that it's proportional because it goes through the origin. Proportional graphs always go through the origin. And we can see that in 1 hour, they produce 6 tons of flour. In 2 hours, they produce 12 tons of flour. 3 hours, 18 tons, and so on. So that gives us a K value of 6 tons per hour. So which production line makes the most flour? Well, 5 tons per hour, 4 tons per hour, 6 tons per hour. Pretty obvious on this one. Line C makes the most. Okay, and since I've already shown my K values here, I've already explained and shown my reasoning. I don't have to write anything else here. I can just put line C. I will accept this as showing work. Okay, same thing for the question on the test. It's a different question, but it's a very similar setup where you have to answer a kind of a similar type of question. Okay, a printing company charges $12.75 to print a single color logo on a t-shirt plus a one-time $40 setup fee. What is the total cost of printing 7 t-shirts? Well, printing 7 t-shirts would be 7 times $12.75 plus the $40 setup fee. And if we think about our total cost being our y value, which we always want that total cost to be the y value, this looks very much like a slope-intercept form equation, okay? So all we would have to do then is figure out the numbers. So 7 times 12.75 plus 40. So $129.25. So then if you think about it, what is the total printing X t-shirts? Well, Y equals 1275X plus 40. However many t-shirts I buy, I have to multiply that number by 1275. Just like here, I wanted to buy 7 t-shirts. So I had to multiply it by 1275 and then add the production cost. And so that's how that works. That's what a slope-intercept equation does for us. Now it says make a graph. And you'll be given a graph, a blank graph just like the one below, and you'll have to label it, number it, and put the line on it that represents your equation. Okay, so don't panic. It'll be okay. We already know that this needs to be t-shirts. So we can label that t-shirts. Oh my goodness, I'm having trouble. This is why I typed on that last problem. T-shirts. This is my x-axis. Good grief. Let's try that one more time. This is my x-axis. This is my y-axis. This is going to be total cost. And this we can number by ones if you want to. For this one, I can't remember on the test, you know, what would be most reasonable for this one. 6, 7, 8, 9. And then I know that for 7 t-shirts, I had to get up to $129.95. So like I don't want to number this by 5s or by 1s, certainly, because then I'm not even going to get up to my $40 startup fee, right? But I want to number this in a way that will let me get up to that 7 and then 129.25. So 30, 40, 50, 60, 70, 89. So 10s won't work. Let's go by 20s. So 20, 40, 60, 80, 100, 120, 140, 160, 180. Okay. And so I know that the y-intercept for my graph is 40, right? B equals 40. And then my slope would be 12.75. That's not very helpful. That's not very useful. But it's still okay to write it down. So, but the y-intercept of 40 is very helpful for me because that tells me where my line has to start on the graph. It has to start right there. Okay? And then the price goes up from that point. Once you start adding in t-shirts, you have to pay more money. And I know that 7 t-shirts costs $129.25, which is right about in there somewhere. That's all I need in order to draw a line, guys. I need 2 points. So I've got my y-intercept, and I've got a point on the graph. And so even though we know the slope is really not very helpful for us on this one because to go up 1275 over 1, that would be very difficult to figure out on a graph like this. But to know y-intercept and then another point out here somewhere on the graph, that's more helpful. So that's how to go through this one. If you're struggling with this one, go back and watch this a couple times. Kind of look at the steps and see how they relate to one another. It's good that they asked this first question because I think most of you can probably um, take the information and figure out how much 7 t-shirts cost. Then use that information to help write your equation, which is good that they gave us this first. Now with this helps me graph it because I know what my y-intercept is. And once I know what the y-intercept is and I have that point that I already figured out, the rest of it's just getting the numbers on the graph, and you should be able to do that. Okay, let's see. Was there anything else on this page? I don't think there was. Nope. All right. Last page. Bill has $200 to purchase donuts and chocolate milk for his company's breakfast meeting. A box of 1 dozen donuts costs $5. A gallon of chocolate milk costs $4. So we already see that D is labeled for us here, so we're going to say D. Well, D doesn't equal 5. We don't want to do that. But a box of donuts costs 5, and a gallon of chocolate milk costs 4. That's the information we're given. So complete the table showing 3 ways Bill could spend all $200 purchasing donuts and chocolate milk. So Bill doesn't get to go spend $50 on chocolate milk and then pocket the rest of the money, right? He has to spend all the $200 on chocolate milk and donuts. So if he buys 10 gallons of chocolate milk at $4 a gallon, that's 10 times 4 equals 40. And then he takes that away. He had 200, so 200 minus 40 is 160. Well, now he's got $160 left to spend on donuts, and that is divide by 5. 160 divided by 5 would be 32. So if he buys 10 gallons of chocolate milk, he would buy 32 boxes of donuts, and that takes all of his money. All right, then what if he bought 20 boxes of donuts? So this would work it very similarly. It's 20 times 5 equals 100. And then 200 minus 100, of course, is 100. And divide that by 4, because that's how much a gallon of chocolate milk costs. So that would be $25. Or no, 25 gallons, sorry. And then they left one blank here for us. And so we need to fill one in ourselves. And this one, I'm going to try to help you here so that we can set up something that's going to help us graph later. This will help. If you make either one of these 0, we're going to find an intercept this way. So if I make chocolate milk 0, he doesn't buy any chocolate milk. He figures, we're all adults. Everybody's going to drink coffee. Nobody wants chocolate milk. So he's just going to spend all $200 on donuts. So 200 divided by 5 is 40. So he could buy 40 boxes of donuts for $200. That's a lot of donuts. Sounds yummy. Okay, so now this one is one of those scenarios that we've talked about through the chapter. Excuse me. This is one of those scenarios we've talked about through this chapter where it's writing a slope-intercept equation is not going to be the easiest way to write the equation. The easiest way to figure out an equation to write. It's going to be easier if we write a different style of equation. And so we know that every gallon of chocolate milk costs $4. And we know that every box of donuts costs $5. And we know that when you add those two things together, it needs to equal 200. Okay? So kind of look at the way I've got this set up here. For the table we had to fill out, I just took that letter, C, and I multiplied it by the number that every one of these, that's what we did every time here. We took 10 times 4. 25 times 4 gives us the money that we spent. Same with the donuts. 32 times 5 would give us the 160. And 20 times 5 gives us the amount of money he spent. So we did that. We basically did those steps every time here. And then we knew that they had to equal $200. So 4C plus 5D equals 200 is the equation. Now, sketch a graph to the solutions to your equation. Be sure and label your number, label and number the axes. So they already tell us on the graph this is C, so this is chocolate milk. I do need to go ahead and label it chocolate milk. And this one is donuts. Okay. So looking at my table, I know that for donuts, the highest number of donuts I have to get to is 40, right? And if I buy 0 chocolate milk, I need 40 donuts. So I can number this axis pretty quick here. I can go by fives. 5, 10, 15, 20, 25, 30, 35, 40. Okay. So I know that at 0 chocolate milk, I need 40 boxes of donuts. Now, what I need to figure out is what if I had 0 donuts? How much chocolate milk would I get if he decided, you know what, nobody likes donuts. We're all adults. Nobody wants donuts. We're just going to have chocolate milk. So we can go back up here to the table and just do it like this. What if I put a 0 in for donuts? And then filled this one in for the chocolate milk. So if I was spend all $200 on chocolate milk, 200 divided by 4, well, that's 50, right? Okay, so 200 divided by 4 is 50. So I could get 50 chocolate milks if I get 0 donuts. Well, that's going to work to make this by 5s again. 5, 10, 15, 20, 25, 30, 35, 40, 45, and then this line, this very last one here would be 50. So those are the 2 dots I need. I just need the 2 intercepts. This would be the x-intercept and the y-intercept. We talked about that. We find the intercepts. You know, if you want to know the y-intercept, you put a 0 in for x. If you want to find the x-intercept, you put a 0 in for y. And that's the way that works. Then all I would have to do is connect those 2 dots. And that's the line that represents chocolate milk and donuts for the company picnic. Okay, guys, again, I'm going to stress one more time. You've got the study guide. You've got a video that you can go back and watch however many times you want to watch it. And sorry, Willow got excited about a noise outside. And the main thing is to have this filled out. So even if you have questions on the test, have this filled out, and I'll be able to help you with seeing how it relates. If you don't have it filled out, I just can't help you. All right. I can't wait to see you guys again. I've missed being at school, and I'll talk to you all hopefully Thursday.